All right, here we go. So let's take a look at the top here first, because this is something we've been learning the whole time. This is something we've been learning the whole time. We are dealing with systems, solving systems. Okay. Now, a system, when we get down to this next problem, I think we've seen this before. You probably have seen it before. This little bracket just means that both equations are part of the same system. So this is where, we had some systems where we had to graph multiple lines, and greater than or less than. We had to shade above or below. It's the same thing, okay? So, but in this case, or I'll say before, when we graphed, we found the solution where they intersect, right? But here, we're going to solve it without graphing. We're not going to graph to solve it. We're going to solve it algebraically. So when I look at this, the main thing and tool we're using for elimination is to manipulating a single equation. We're going to manipulate a single equation using the tools we already know, and that's going to set us up to be able to combine our two equations and eliminate one of our variables. And that's kind of conceptual. Let's go to what we know first. Okay, so if you have this equation, x plus 2y is equal to 10, right? If you multiply both sides by the same value, you haven't changed the integrity of that equation at all. You could multiply both sides by 10. You can multiply both sides by 1,000,000. You can multiply both sides by a half, and that would be doing a fraction. That would basically be dividing each term by 2. Okay, so there's different tricks we're going to use. Mainly, we're going to be using the tool of multiplying some value on both sides of the equation just to convert it to something that's useful. Because this equation here, right, if you solve for x and solve for y here, those same values for x and y would work for this equation. All we've done is multiply both sides by -2. We haven't changed the integrity or the balance of an equation with this. Okay, so this is a tool we're going to use. If, let's see, thumbs up, sideways, down, you guys feel pretty comfortable just multiplying both sides like this? I mean, it's kind of like a step, right? It's just like a step. Good, thanks. It's a step just within, all right, thanks, solving an equation, right? It's easy. Okay, so just keep in mind, the step we're using is exactly the same as what we've done. The slight change in addition for today is that we are doing it. We're doing the same process of elimination to set up negation if needed. Let's see, somebody give me an example in the chat of negation. If I had +5, what value would I need to negate +5? What value would I need to negate out +5? Good, Arnold. Anyone else want to take a guess? Take a wild guess. It happens when we, it's like x plus 5 and we want to get rid of the +5. So what do we combine? What do we need if I have +5? What do I need to combine with it to negate it out? Good, Lily. Close, Cadence. Close. All right. So I'll give you like the scenario up here. This isn't anything new. I just want to kind of keep reiterating that and give you different examples. If I had x plus 5 is equal to 10, and I want to solve for x, when I negate out, right, Sophia? When I negate out, I'm just going to do, let's see what happens. +5 minus 5. This, when we can cross these out, when it adds to give us 0, that is negation. That's negating. Okay. Negation is just combining a term with a term that will have a sum, a difference, whatever, of 0. So it goes away. Okay. So that's negation. That's all we're using for elimination. We're using the process. Do the same process. Do the same in process of elimination to set up negation if needed. Okay. So if needed, right? Let's look at this first situation. Because what's going to happen here is I have a system here, and we have too many variables to deal with. So elimination allows us to get rid of one of our variables. Now watch. First, I want to look to see, okay, x, because what we're going to be doing when we do elimination is we're going to be adding together our two equations. We're going to add the x's, we're going to add the y's, we're going to add the numbers, okay? And that's going to give us a new composite equation that we can use to solve for the variable. So elimination is negating out one of the variables in order to make it easier. So if I combine these, which of my variables, we don't have to do any manipulation to it, but which variable is going to be negated out if I combine, if I add these? Tell me in the chat, which variable is going to be negated out? Good, Rocco. Anyone else? You just have to put, yep, Yancy, Cadence, Arnold, good. Sophia, good. Curtis, yep. All right. Good, good. Janice, good. All right, so when we combine and we add these two equations together, look what happens. X plus x, 2x. Positive y minus y, 0. We don't have to put it. Those cancel out. Over here, 2 plus 0 is 2. So last step. Now look, now we can solve this very easily because we've gotten rid of one of the variables. Watch. Divide by 2, divide by 2. X is 1. Okay. So remember that because these systems have x and y, we're not just solving for x alone, we're solving for x and y. So we know that our x value is 1. How can we find the y value if we know the x value? Tell me in the chat. Axel, I want you to think of it as add. Yeah. Yeah. Let's see. That's it. Yep, everyone's getting it right. All right, so what we're going to do is we're going to pick the easiest equation up here to deal with. Easiest equation is the top one because everything's positive. And we'll take that top equation and we're going to plug in 1 for x. We'll then subtract 1, negate on the 1 on the left side, y is equal to 1. All right, so we found our two values. You just got to remember that the answer is going to be an ordered pair. Okay, you got to give your answers as ordered pairs because it's a system and there's an x and there's a y value to it. Now, the reason why I only suggest adding is if you use elimination and you use subtraction, which is possible, but essentially if I were to have subtracted the bottom values, this here, there's an aspect to having to distribute the negative and then you just end up adding anyway. Okay, so instead of thinking of it adding or subtracting, I want you to think of it as combining in order to negate. Okay, the most direct way where you don't end up with anything that is a little bit trickier is just to add them. Think of it as add. Okay. Okay. They're both equal to 1. Then 1 is an equation. X plus x is equal to 2. Oh, I see. Well, good question. Since they're both equal to 1, right? Why wouldn't this equation? Well, look, if x is 1, I put a 1 there. If y is 1, I put a 1 there. 1 plus 1 is 2. Okay. You are correct that because this is an x and that's a y, this equation on the top here would be correct if it had x plus x is equal to 2. But that's just not what we have. Okay. So I think it's good to be able to see it that way, that, sometimes if you end up with the same value for x and y, when you end up with the same value for x and y, they're interchangeable. But that's not something that's kind of like just like tangentially cool abstraction that you see, but it's not necessary. Just in the nature of how we're doing this. Let me see. Good. All right. All right. So give me a thumbs up, sideways, down. Everyone feel good about example 1? Yeah? Excellent, guys. You guys doing great. All right. Example 2 has a little bit more to do. I was going to go for like some rhyming there, but then I just decided not to. Well, not do it. Okay. So this second step I didn't bring up because we everyone already knew to do it, but use solve variable to find the other, to solve the other. You just got to plug in. Okay. All right, let's take a look at this second equation here. Now with this one, if we just added these, we don't eliminate, we don't negate out We don't negate out one of our variables. So there's one value that we can multiply one of our equations by in order to set up a negation situation. So tell me in the chat, what are your instincts with this? Which equation should we go after, and what should we do? How should we manipulate that equation to set up elimination? What do you guys think? Yeah. Rocco, check your sign on that, though. Cadence, perfect. Because just multiplying by 2? All right. Okay, I see. Good, Haley. Good, Haley. Nice. Good. Anyone else want to give take a guess? It's free guesses. It's free guess day. Whoa. All right. Okay, I like these ideas. Everyone is narrowing in that we're going to look at the top equation. We're going to look at the top equation. And you know what? Just so I can keep this nice and fresh for my next class, I'm going to just rewrite it and cover it. All right. So we have this situation here. Now, a lot of people were saying, all right, let's multiply the top one by 2. Now, why is that not quite our best option? Why is that not quite the best option? There it is, Rocco. Is that what you meant the whole time? No, but you get it now? Okay. All right, let's see what happens. If I were to just say 2, the idea is to make this y 2y, right? But remember, we're always adding. We're combining these two equations. So we need one of them to be negative 2y if I want to focus in on y's, while the other one is 2y. If I make it negative 2y, then when I combine them, it negates out and we get 0. Remember, combining, we're always going to add them. Okay, so watch. We're going to multiply by negative 2. Negative 2. Now does it make a little more sense? A bit? All right, we'll have to do another one, I think. No worries. Look, I'm going to rewrite this, and I'm going to distribute this negative 2. We get negative 16x minus 2y is equal to positive 32. On the bottom, we have negative 6x plus 2y. Ah, now I see. Now I see. I'm setting this up. Oh. Right? We're setting that up. We're setting up a situation when we add the two equations. When I just combine the two equations, what's going to happen to what I highlighted? Negation. That is the name of the game for elimination. Watch. See ya. I just made it twice as easy. When I combine these, negative 16 underwater 16 feet, go down further 6 feet, we get 22x is equal to 22. Ah, test maker's hat. I know I'm on the right roll. I'm on the right track. Right?
Doesn't the 22x have to be negative?
Woo! Starburst thrown across the city to you. Thank you. I was excited. I just got excited. That's all. Thank you. All right, so last step here is to divide by negative 22. Divide by negative 22. That cancels it on the left. We get x is equal to negative 1. That's part of our answer, right? Part of our answer is negative 1, but we got to find the other part of our answer. Now, here's the thing. You can, remember, we've done half of it. You can take your x value and plug it into any of your equations. Even if you wanted to plug it into this one, right, way down here, or this one after we've manipulated it, or this one, or the original, right? You can plug it into any of the steps and it will work because we have kept the integrity of all of our equations. If we multiply both sides by the same value, it is the same ratio, the same balance of our equation. So don't worry about which one do I pick. There isn't a wrong choice. There's just a better choice. Okay. So when I'm looking for the better choice, I think I have to go back all the way to my original equations, because look, if I'm solving for I'm solving for y now. If I plug it into my original equation up here, the top one, y is already set up. It's positive y as my answer, so there'll be less steps to do. So I'm going to take that one down here. 8x plus y is equal to negative 16. Remember, it's your choice. It's your choice which one you plug into. So just make sure you're making your life as easy as possible. Path of least resistance. When I was a kid, I was like, path of least resistance? I want like the path of the hardest resistance. I want the tough road. That's stupid, right? It's not, doesn't make sense. Path of least resistance. Go the easiest path. Don't make life harder. It's hard enough. So we're going to plug in -1. We get -8 plus y is equal to negative 16. Let's do our last step here. We're going to add 8. We're going to add 8. Negate. Y is equal to -8. All right, you got to put that in there. This is the answer. With systems, you need your answer to have x and have y. Okay.
Wait, I'm confused. If we're trying to plug in x for that, like, where does the -2 go?
I see. So what I was pointing out is once you get one of the variables, you can plug in your x value into any of your equations that you've set up. You can plug it into your original equations. You can plug it into your manipulated equation after you've multiplied -2 and gotten down here. You can plug it into this one here. It doesn't matter because we multiply both sides by -2. This equation is just as balanced as our top equation. The relationship between left and right are still equal to each other. So I would say, though, it's always a good thing. The equation that you're going to plug into is probably going to be one of your first original equations. In fact, I'll say that's always the easier route. Okay, so once you find one of your equations, go back. This is some of the manipulation. Go back to your original equations, your two original equations before you manipulated it, and decide there which one you want to plug into. So if you were to have plugged in -1, down here after we've manipulated it, you would still get -8. It'll always work out that way because we've manipulated both sides by the same amount. Okay, so at the end, we'd end up dividing by the same amount. We'd end up with -8 no matter what. But I think that's a good point. As far as this thing goes, this one goes up here. Use solve variable to solve the other, and use let's go from original equations. Okay, from the original equations. Does that make more sense like that then? If that's kind of like a step.
Yeah, thank you.
You're welcome. All right. Let's see. Let's go ahead and zoom out so you can get a screenshot if you need it. That is the whole, that's as much as I can get. All right, take a screenshot if you need it. Does anybody want to see one more problem? Tell me in the chat or, good, Arnold. You got a good teacher. Nope, feeling good? Somebody speak up if you want to see another. I won't name you. Nah. These are the two types you're going to have. These are the two types. The only other next level, and it's what you'll see when you get to like math 2, 2+, 3, 3+, is, so some of you already learned this. The only more difficult thing that you'll end up with is you may end up where you don't just multiply one equation by some value. You may have to multiply this one by like -2 and this one by +3. There's going to be situations like that. You're going to see that when you get to the next levels. And if you like right away, you're like, yeah, I could see how that would work. Then don't even worry. Don't even worry. All right. Okay, good. So good. So some people are commenting that they learned this in 8th grade. Okay. Some people had different experiences second semester in 8th grade because of COVID. So there are some things that we are relearning, but this is a standard that is covered as well. And And you may not have gotten as far into the manipulation part for some of you, so I wanted to definitely go over this again in depth. All right, thanks for watching the video, guys, at home. Bye.